I work at Realm right now, where we have this database product, and we built a new synchronization server thingy. And this database product mostly is used on mobile devices, so the synchronization happens between mobile devices. And for that we needed, because the database is written, it's actually just a file, and you can't really browse that file with your normal OS tools, so you need a browser of those files. So we came up with a way to actually do that, both in like a web world, but also as a desktop app through Electron. Only writing the code once, but actually getting 4 platforms, or however many you want to say the web is. So, what is a platform? The web is a platform, and if we say that we are actually JavaScript developers, we want to write JavaScript everywhere. So we do that in the browser, in the front end, and we want to support generally any browser for some definition of any. I don't want to support IE9 anymore, but that's maybe just me. If we are doing something on the back end, maybe it's Node.js, it probably is, or something that compiles to something that can be run on Node. The front end and the back end in the web world communicates over the network somehow. That can be WebSockets, HTTP, whatever. That doesn't really matter. It's through the network. That's the important point. So Electron, how does that differ? So what is Electron first? Electron is Node and Chromium and some more stuff bundled together in one big pile. So you have your Node process that you know and love. You have your Chromium browser that you know and love with the debug tools you know and love. And then you have some native bindings. So you can do stuff like making the native OS X menus. You can do IPC. You can do whatever you sort of want to do natively, more or less. So that's Electron. And it works on the Penguin, on the X, and the Windows. So that's perfect. Great. We have three platforms here, and we have 1 platform on the web and all your phones. So that's at least 2 more, and so on and so forth. So that's cool. So in Electron, everything is actually JavaScript or native code, but let's ignore that for now. So you write your UI in to be run in an embedded Chromium, as I just said. You write your backend to be run by an embedded Node.js. You can still do whatever transpiling, compiling madness you want to do. That doesn't matter. You run it on Node. And then there is all the native stuff. So menus and notifications and IPC and the OS interface and what have you. So one important point here is that you can do UI to backend communications over the network with HTTP and WebSockets if you feel like it. You can also do IPC, you can do sockets, you can do whatever. So where does that leave us if we want to write the code as much as we can once and then run it everywhere? It leaves us sort of here. So this is a diagram of how you do this in the way so that you can avoid rewriting everything. So you write 1 front-end component, you write 1 back-end component, you make sure that they communicate over the network because that's what the browser supports and you want to support the browser. Yes, you can do other stuff with Electron, but if you don't need it, just don't. And then there is a sort of separation line where you have to have some platform-specific code. And for Electron, that's something like native integration. Maybe you want to have keyboard shortcuts. Maybe you also want that on, in the browser, but yeah, that's another talk. You want to do some configuration. You want to package your app in some way, and so on. On the web, you want to do some integration maybe with other systems, and you also want to configure it, and maybe you want to minify it. That doesn't matter so much in Electron and so on. So this leaves us with 4 very simple rules. The first one is don't write intertwined platform-specific and non-specific stuff. So you know you're going to share something, so make sure that you write it so that it's shared and it's separate from the platform-specific stuff. As I said, front-end and back-end should communicate over the network if you want to reuse your code. There is an escape hatch here. Obviously, if you think that this is too slow for your desktop and you want to get the maximum speed in Electron, you can do that by writing small adapters instead. You have to make the shared components configurable because they have to behave nicely in both environments. And you have to use standard web technologies and shared components. And that means, support the browsers you care about, do the polyfills, the compilations, support all the old standards, whatever. And the backend, use the standard Node.js API. So that was me talking for a while. Does anybody have any questions? Perfect. Here is some code. Okay, so I wrote a small project just to show how this actually looks in practice. So let's just have a look. So I have here some stuff, and I have a package.json. So I have 3 entry points to this project. Let's just run it first. Maybe. Who knows how this will work? Yay! So this is a front end. I can type some stuff. I can type colons. I can type horse. And I can type another colon, and I get an emoji. So this is done in a Node.js library that simply looks at my text, and it does some stuff. It gives me an emoji string back. So I can do stuff like that. But it showcases what we're doing here. So this is obviously a front end. It's a small front end I wrote in React with the help of Create React App. So that's super quick. So it doesn't really do much. What it does is it has some files. It has one component with I didn't overdo it on the components here. So it has a form, an input, it has a change handler, and that change handler asks for a translation of the string that it got. Can you see this in the back? Okay. For the string that it got, and then whenever it gets the translation, it updates the state and re-renders. So this is completely, you can use this both in Electron and the web, right? The only thing I did, which was sort of to make sure I could use it in both places, was to make a separate translation service so this communicates over the network using fetch, but I could also have done the communication over IPC if I wanted to. But in this case, let's stick to network. It's the simplest. Okay, so that's the front end. Super simple. On the back-end side, I have 2 things. I have the emoji translator thingy. So that's just a small web server. It gets a request on some path, and then when it gets that, it looks at it gets the parameter from the request, and then it throws it at this emoji thing function and that gives me a string back, and then I can return that. So that's simple and cool. And that listens on some port that you can specify, and by default I just start with some port. So that's a simple web server, and similarly, so this is a service, I guess, and similarly we have a web server that I use to just serve the static files, just because I didn't want to get them from the file, from like a local file URL, whatever. So this allows me to run, to pretend that this server is running on the web, or to run it inside Electron. So that means that I have my Electron thingy running. Let's close that. And then I could say, I could look at my screen. Stupid project name. I can run the emoji service, and I can run the, what did I call it? This? Yes. So now I have two services, and I have a local host thingy, and I have maybe the same thing. So what just happened? This is just a standard web server thing, and the Electron thing is also the same standard web server thing. It's just wrapped inside a bundle, which is called Electron. So what code couldn't I share in this project, I wonder? This code. That's the custom Electron code. So this is not magic. It's not even very hard. Yeah, I just wanted to share it because I think it's pretty cool that you can share so much code and not actually care about all the things around it. So that is it for me. Questions?